So part 6b. By factorising x squared minus 3x, or otherwise work out the smaller solution of when x squared minus 3x is equal to a half x minus 3. Okay, so we'll read the question and we'll look at analysing the question a little bit. So by factorising or otherwise, okay, so we're given the opportunity to use a multiple techniques, if you like, in order to work out this answer or to work out the smaller solution. And that's also another key part, the smaller solution. So that means there are two solutions, okay? Now, we're going to look at this in two different ways. One, we're going to look at it more visually, and the second is we're going to be looking at it more algebraically. So first, looking at it more visually, where we have the graph, okay, where we have a curve, we have a parabola, and we have a linear equation, a linear line, okay, a line going through here. And now, what it means is when x squared minus 3x equals a half times x minus 3, what this actually means is when the line and the parabola are equal, when they cross or when they intercept, that's what it's saying, and we need to find the x coordinate and the y coordinate of those points retrospectively. So this here, illustrated by me circling, these points here are when, obviously, inside the center of these points, when the line crosses the curve. These 2 points are when this is true, okay? That occurs when these are the same, okay? Now we can use some information from one of the values, because we know that the x point here, the point when they intercept, is when x is equal to 3. Hang on a second, if we can get this working. When x is equal to 3 and y is equal to 0, we can tell that because y is 0 here on this plane and then x is 3, and this is where they both cross, okay? So when we substitute these values in, so when we substitute an x value into here, it should be equal to the x value on this side, which would be 0 if you like, because that's these are the y coordinates. So when you substitute 3 into here, you get 9 minus 9, 0. You get 3 times 3 minus 3, 0 times a half, so 0 equals 0. That's true. Therefore, the y value where they intersect is 0. Okay, so that's correct. But what about this? This is our smaller solution, right? So we need to find out what this value is. Well, we don't actually know what it is. So what we need to do is use the more, if you like, algebraic perspective to be able to solve it accurately, because you could guess what it is. You know it's less than 3 on the x-axis, and you know it's greater than minus 3 over 2 on the y, but you know, you can keep that in your mind, but in order to calculate it more accurately, we need to look at the algebra to it. So let's crack on straight away. So in order to solve this, in order to find what the x value is, we need to form a quadratic equation, okay? So what I'll do is I'll start off by multiplying out by 2 for both sides, giving us 2x squared, let's just do that 2 better, 2x squared minus 6x is equal to x minus 3. Okay, so we want all the x terms and all the constants to be on one side, making the quadratic equal to 0. So 2x squared minus 7x plus 3 is equal to 0, right? So you've seen this form before, where you have a as the coefficient of x squared, b is the coefficient of x, and then obviously c is the constant. And in order to solve this, you could either use the quadratic equation, or you can complete the square, or even try and have a go at just using basic factorization. So we're going to give that a go now, and if this doesn't work, then we'll use one of the other methods, because it might not always be clear to what the factor is. So we're going to just have a little sign here, because then we can make that a positive if we like. So we need to make 3. Okay, so in order to make 3, we can only have these two numbers, right? So we can only have 1 and 3, but we need to make minus 7. So we're going to have this as a negative, I think, and we're going to have this as a negative, because then negative 1 times negative 3 is 3. So when we expand this out, we will get hopefully the right values. So 2x squared, which is good, that's good, and then we get minus 6x, which is nearly there, minus x, that's good, and then we get 3. Okay, so we've factorized it, it's all correct, And now we need to look at what the two x values are. Well, we know one of the x values for which this is true is when x is equal to 3. Okay, so when we need to look at this value here, when 2x minus 1 is equal to 0. So when 2x minus 1 equals 0, x is equal to a half. So what this means is the x coordinate of this intersection point here is equal to 1/2. So how do we find the y coordinate, if you like? Well, I've just notated that this is the second y point of the smaller solution. We don't know what it is, and in order to find it we need to substitute our x value into either the line equation or the quadratic equation, because whatever one we put it in, it will give us the same y coordinate, because that is the point in which they are both the same. So we're going to use the linear equation, I think, because it might be slightly easier to use. They're both pretty simple, but we'll use that. So substituting x equals a half into a half, y equals a half, x minus 3, half times x minus 3, we get y equals a half times a half minus 3, so we get a half minus, times minus half times minus 5/2. There we go, the pen's working now, like so, and then we multiply these out, so we get minus 5/4, right? So this is our y2, if you like. This is our y2 coordinate. Okay, so therefore we can conclude, we have a little therefore symbol here, that the smaller solution of x squared minus 3x equals a half x minus 3 times x minus 3 occurs at point a half minus 5/4, right? And this will give you this will give you the marks available for the question. Okay, so that's it on question 6. See you in the next part.